Hi guys, in this video I am going to have fun with math. I'm going to use integration to find the area of regular shapes like rectangle, circle, even squares maybe, or parallelogram or trapezoid, trapezium, well, anything you like, really. If you want to try by yourself, that's good. By the way, this is not really a tutorial video, but this is just having fun with math. And I'm not trying to derive the formula of those basic area formulas of shapes, but I'm just trying to do some examples and shapes that I'd like to try. So yeah, by the way, math is fun. Math is literally everywhere. Okay guys, in this first example, I have a triangle ABC with these coordinates A11, B15, C31, and we have two functions involved for this triangle shape on coordinates, and ABC, there you go, and fx is this side BC. This equation can be easily found using gradient or straight line equation. Y is equal to mx plus c, stuff like that, and gx is just a horizontal line. Y is equal to 1, gx is equal to 1. What about side AC here? We do not need functions for side AC here because we will use the interval of integration. To be more precise, side AC will be the lower limit of the integration. So if we are using the basic formula of area of triangle, we can easily find that the area is half times base 2 times height 4, which is 4. But here we are trying to have fun with integration to find this triangle's area. We're just having fun with math. Yoo-hoo! Okay, so we just use this integration fx minus gx, of course, interval 1 until 3. This a side AC will be the lower limit of the integration, right? And yeah, fx minus gx, because in this interval fx is larger than gx or higher than gx. So we just subtract and then integrate directly because this is quite easy. You don't need substitution or something special for this integration. So you just integrate directly and then calculate. Simple. You can pause the video if you want, but I don't think you need to. Then we have 4. So yeah, it is correct. The area of the triangle is 4. Okay, in this second example, I am using rectangle, a simple rectangle. However, I'm not using any numbers here because I am just using variables here to make a more general formula or general example. Well, also to mix up things with my other examples, yeah. Just having fun with math here. So let's go. Here we have fx, this top vertical horizontal side, and gx is the bottom horizontal side, and it's going to be constant. Yeah, a b c d here are just constant or real numbers. Here is positive. And about these vertical sides, left and right vertical sides, we do not need any functions here because we will just use the interval of the integration. The left vertical side will be the lower limit of the integration, and the right vertical side will be the upper limit of the integration. Pretty simple. So we just use the integration fx minus gx. That's obvious because fx is larger or higher than gx in this interval AB. And then just plug in and then integrate directly because it's easy to do. And then in the last few steps, we have some algebraic manipulation or modification here to have regrouping here, so that the last form, the last expression will look like this, b minus a times b minus c, so that we can conclude that it is actually length times width or length times breadth. Okay, in this third example, I'm using circle right now. Yes, it might be more complicated than triangles, shapes like that, involving straight lines only, because in circle we have curves, no straight lines, just curves. Here I have center 4, the radius is 2. Okay, this is the center, radius is 2. And fx and gx. Fx is the top part of top semicircle and gx is the bottom semicircle. How did I get these equations? Pretty simple, guys. We just need to modify the circle equation in standard form and then make y as the subject of the equation. It is just like putting only y on the left hand side of the equation. For fx, gx, it is like y, right? So yeah, the plus here will give us the top semicircle, and the bottom here will give us the bottom semicircle. Okay, by the way, you can watch my other video about circles and semicircle or even quarter circles equations. It is still simple, just using the basic standard circle equation and then we play around with the equation. Okay, let's move on. Of course, if we are using the basic formula of area of circle, we can find easily and fast that the area of this circle is pi times 2 times 2, which is 4 pi, or we can round it off to 12.56. Yeah, and then the area of circle. Now let's play around with the integration. Of course, it's fx minus dx because fx is higher than gx in the interval 2 until 6. And then we just substitute, plug in, simplify as much as possible here, and we end up with this expression, square root. Squared inside square root. Awesome. Looks difficult. And by the way, there might be many ways to solve this kind of integration, but here I'm sharing one of ways. Well, I like this way. Yeah, let's go. So first, of course, we do not like this x minus 4 expression, so substitute it with u, and this is important. Do not forget to modify the interval, lower limit and upper limit, following the substitution that we use. So x changed into u following this. Yeah, you can see this. Yeah, the new u for each 2 and 6 will be the new interval. It will be minus 2 until 2 for u. Now everything is in u, and the next problem we have square root, squared under square root. Now this might be a little bit special, but I hope you guys already know about this kind of technique, or I don't know, it's not even, yeah, just this kind of knowledge. When we see this kind of expression, square root of ax minus x squared, square root of a squared minus x squared, or square root of a squared plus x squared, or square root of x squared minus a squared, we should substitute to this. We use this substitution. X is equal to a sine t, x is equal to a tan t, x is equal to a secant t, sec t. And then for this case, it's like a squared minus x squared, right? So we will use this substitution. X is equal to a sine t, and the dA here should be 2 because 4 is 2 squared. So yeah, we are using this, but a is 2 in this case. We can keep in mind that this kind of substitution is a little bit weird because usually we do t is equal to something in u term, but this one is the u term, the one here, is substituted by something else. So it's a little bit reversed, but not really. Hope you are familiar with this kind of substitution integration. Okay, so yeah, again, do not forget to modify the interval, lower limit and upper limit following this. Now, however, this we have to inverse first because we will change everything from u term to e term. Why I need this? So that we know that, let's say u is -2. What is the t value of that -2? And let's say u is 2. What is the t term, t value of this one? And then after we are done with the interval modification, we put them we put them here. Oh, minus half pi until half pi. Awesome. And also the u substituted by this, and do not forget the du, yeah, because it's just dt, but it is something differentiated from this substitution. And then we just simplify. With this one, just simplification. I really wrote step by step. You can pause the video if you want, but it is quite self-explanatory if you read this step by step until this part. So much simplified, yeah. So many little steps to make this simplified. And then now we have cosine squared. Well, do not forget this powerful double angle formula involving cosine 2x, and with a little modification we can express this cosine squared into 1 plus cosine 2x over 2, or half plus half cosine 2x. And then yes, we just use this final expression from double angle formula cosine 2x and then substitute it here. And of course, again, simplification and calculation. And we have long calculation here, but if you follow the details, it is quite self-explanatory. You can pause the video if you want, from this one till here. Yeah, luckily the second part here, it gives us 0. So we have 4 pi here in the end after all this calculation. 4 pi, that's the area of that circle. So awesome, right? Something very simple here. This pi times 2 times 2 can be so long like this. That's the beauty of math. And then just a special addition information here. Let's say we're just having fun with integration here. What if the integration is indefinite integration? We do not have the interval 2 until 6. Yeah, we are still using the same method that I used before. Substitution, then special substitution using the sine or tangent or secant. And then also the double angle formula. And then in the last step, we should convert the variable back to x. T to u and then u to x. That's why it looks so ugly here. Arc sine inside sine. That is. But yeah, if it is indefinite integration, it's going to be like this. And let's say if we substitute in the value, the original interval, which is 2 until 6, we will still get 4 pi. You can try that one and have fun with this.